Entire city blocks reduced to rubble. Roads snapped in half. Right now, more than 40,000 people are missing in Venezuela. This devastation was caused by a terrifying chronological anomaly. A massive 7.2 magnitude earthquake struck the coast. But the ground had barely settled when, exactly 30 minutes later, a shallower 7.5 magnitude quake tore through the exact same region. And here's where a local disaster becomes a global mystery. At the precise moment that second quake hit South America, another 7.2 magnitude earthquake ruptured on the opposite side of the planet, in Japan. It is entirely rational to look at events like this and feel a sense of dread. Are these distant fault lines physically reacting to one another? Is the Earth's crust destabilizing all at once? We are looking at an invisible, highly interconnected global seismic web. Mapping how energy travels through that web is the only way to protect ourselves. This map shows the tectonic reality of the Caribbean. The Caribbean plate is constantly grinding eastward, while the immense South American plate pushes west. When they snag along this strike-slip boundary, immense pressure builds for decades. The reason the second quake in the Venezuela doublet was so lethal comes down to depth. It struck just 10 kilometers below the surface. That shallow proximity amplified the ground motion, creating violent, jerky shockwaves that easily pulverize concrete foundations. And that massive release of kinetic energy doesn't just dissipate into the dirt. Seismic surface waves from an event of this size actually circumnavigate the entire globe multiple times. As these waves travel, they can initiate a process called stress loading. When the traveling kinetic energy rolls through distant fault lines that are already under high tectonic strain, it can push them past their critical threshold and trigger a rupture. We know this happens because the planet has a memory. In 1812, an almost identical doublet earthquake struck Venezuela, flattening infrastructure and resulting in tens of thousands of casualties. But the 1812 event didn't happen in isolation. That exact same year, synchronized ruptures tore through the New Madrid seismic zone in the central U.S. and the San Andreas Fault in California. Our planet's fault lines communicate, and they can synchronize. Beyond just its internal heat, the Earth's rigid crust is constantly being physically manipulated by the gravity of our solar system. Consider the moon. During lunar king tides, when the moon is at its absolute closest to Earth, that gravitational pull literally warps the Earth's crust. It pulls the rock upward, adding physical stress to fault lines that are already stretched to their limit. Then there is the sun. We are currently observing a distinct correlation between earthquakes and solar activity. Specifically, charged solar wind ejected from dark regions on the sun known as coronal holes. During the synchronized earthquakes in Venezuela and Japan, the Earth was actively being bombarded by high-speed solar winds traveling at 600 kilometers per second. These immense cosmic fluctuations disturb deep volcanic plumbing systems as well. It is why we see massive events like the historic Hunga Tonga eruption, and why deep tremors are currently shaking 50 kilometers beneath Mount Fuji. Earth functions as a breathing component within a larger cosmic clockwork, making global seismic spikes an expected physical reality. This global transfer of energy means certain regions are currently sitting at maximum stress. The data points toward the fault lines in Japan, California, and Colombia as being heavily loaded and vulnerable. These risks highlight a vital truth. Shaking ground rarely kills people. Collapsing human infrastructure kills people. We cannot stop the tectonic plates from grinding, and we cannot turn off the solar wind. But by tracking these interconnected patterns, we gain the foresight to prepare. Modern alert systems capitalize on this foresight. When a fault ruptures, it emits a fast-moving, non-destructive energy ripple called a P wave. Alert apps detect this wave and instantly warn your phone, giving you 5 to 15 seconds before the destructive shaking arrives. That 15 seconds is your window to survive. If you are near an exit, get outside and away from buildings or large trees. If you are stuck inside, take shelter under a sturdy table or doorframe to protect your head and neck. And when the shaking stops, the infrastructure will likely be compromised. That is why you need a bug-out bag pre-packed near your door. A proper kit requires slip-on shoes to navigate broken glass, emergency rations, and a hand crank radio to receive updates when the power grids fail. Human survival depends on our shared capacity to prepare and protect one another when the ground finally breaks.